Watch a giant military transport plane lumber down a runway, and you have to ask yourself how something this massive actually gets off the ground. A fully loaded C-17 has a maximum takeoff weight of 585,000 pounds. That is the physical equivalent of 40 adult elephants. It defies our intuition. How does an object holding that much metal, fuel, and cargo break contact with the Earth and float in the sky? Yet this impossible feat happens roughly 100,000 times a day in the United States alone. Tens of thousands of commercial flights execute this heavy lift every single day with absolute routine. If you took a high school physics class, you likely heard a textbook explanation for this involving the shape of the wing. It's curved on top and flat on the bottom. The theory claims that as the wing cuts through the sky, the incoming air splits. Because the curve makes the top surface longer, the air traveling over the top has to speed up to meet the bottom air at the exact same time. This faster air creates a low pressure zone above the wing, sucking the plane upward. It sounds perfectly logical, but it is completely wrong. You can test this yourself with a piece of paper. A folded paper airplane has completely flat wings, lacking any kind of curved airfoil, yet it glides beautifully. Or consider acrobatic stunt planes. If a flat bottom and curved top were required to stay airborne, rolling that plane upside down would instantly create reverse lift and send the aircraft plunging toward the dirt. The air molecules splitting at the front of a wing are under no obligation to meet up at the back. So if the standard diagram is a myth, what actually holds 500,000 pounds of steel in the clouds? The engines and the wings serve two entirely different purposes. Looking at a jet engine, it's easy to assume its power is what pushes the plane up into the sky, but the engines only provide forward thrust. They are giant metal tubes burning fuel to do one single job: shove the plane's enormous weight straight forward at high speeds. Think about walking chest deep through a pool. You can physically feel your body shoving the dense water aside as you press forward. The atmosphere is just a thinner fluid. As the engines blast the plane forward, the wings act as physical barriers. They violently divert the incoming air, forcing it to bend around them. That forced bending of the air is what alters the air pressure. This interaction is governed by Sir Isaac Newton's third law of motion. For every action, there is an equal and opposite reaction. Wings are pitched slightly up against the wind. This is the angle of attack. As the plane races forward, this tilted surface aggressively grabs the air, forcing it into a downward vortex. The opposing reaction to this downward force shoves the airplane up. It is the exact same mechanical process that keeps a helicopter in the air. The spinning rotors hurl a heavy downward draft toward the dirt. An airplane is doing exactly that, just stretching the process out horizontally across miles of runway. This presents a very fascinating logistical problem. If you are balancing a metal tube on top of a roaring column of downward moving air, how do you steer? There is no steering wheel turning tires on pavement. Instead, pilots rely on control surfaces, small adjustable flaps on the edges of the wings that alter how air flows over each side of the plane independently. To turn, a pilot will bank the aircraft, dipping one wing lower than the other. When the plane tilts, the entire upward force of lift tilts sideways with it. That sideways push acts as a centripetal force. It physically pulls the heavy aircraft out of its straight line and drags it smoothly through a curve. When Wilbur and Orville Wright engineered the first powered flight at Kitty Hawk, they didn't have modern aerodynamic computer models. Their original flying machine lacked those highly engineered curved airfoils. Instead, their wings were simple pieces of cloth stretched taut over wooden frames. Their genius was highly intuitive. They recognized that pitching a flat surface slightly into the wind was all it took to force a physical reaction from the sky. Modern aircraft master the atmosphere through physical force, using powerful engines and carefully angled wings to stay airborne. So the next